So along with learning about parallel and perpendicular lines, in a geometry sense, we're also going to review what you know about parallel and perpendicular lines from Algebra 1 last year. So we're going to start out by discussing what slope is, which it can be thought of as a formula, or it can be thought of as a word over a word. Probably very familiar with the phrase rise over run. Okay, so that's what the slope is referring to as a line changes on an XY graph. The equation that goes with it is where you subtract the y's in the numerator, subtract the x's in the denominator. Okay, the reason that those little subscripts are there, those little numbers 2 and 1, are just ensuring that you subtract the coordinates in the same direction. So looking at the differences between these green lines here, I'm referring to a characteristic that would go with each one of these. So when the slope is going down, and the way that you know that it's going down is if you put a little stick man on there, he's always walking in the direction that you read. This would give us a negative slope. A positive slope, the guy's walking uphill. Then the next two, some kids switch these two around, but a good way to remember it is that he can walk on this line. Okay, so this is a slope of 0, but he can't walk on this line, and in fact he's hanging on for dear life. Okay, so this is undefined. So vertical lines have an undefined slope. Okay, undefined meaning when you find the slope, you get a number over 0. Okay, so if you ever get 0 in the denominator, that's an undefined slope, a vertical line. So using this equation that we highlighted up here at the top, we're going to practice finding the slope. So you can subtract the y values in any order that you want to. The x numbers that you subtract just have to go in the same order. So if we subtract in this direction, remember you have xy and xy, so subtracting the y's would produce this, 0 minus -4. We have to subtract the x's in the same order. We can't draw the arrow the other direction. Okay, and then we're just simply going to simplify this fraction. To give us our slope. Slopes can never, ever, 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 ever be decimals or mixed fractions. Okay, you may have had a teacher that has told you that it's okay, but in this class it is not okay. Okay, it needs to be an integer or a fraction or improper fraction. No decimals, no mixed fractions. Okay, so let's look at the next one. We're going to subtract our y values. Let's try going this way this time. It does not matter which order you pick for the y's. And then that means we'll subtract this direction for the x's. Okay, the negatives cancel out and we get 11 over 12. So if they ask you to find the slope, that is the process to do that. All right, moving on to the next slide. Slope-intercept form. This is the easiest form to graph lines from because it gives us all the information we need. Okay, we always start by graphing the y-intercept, and then we use the slope to find the next point and connect those two dots. So I'm going to show you what I'm requiring as far as graphing. Okay, so if we're trying to graph this first equation here, what you're going to do is you're only going to draw dashes where you need to. Okay, I'm going to assume that you know what the x-axis is, the horizontal one, and the y-axis, the vertical one. You don't need to label them. We're moving beyond Algebra 1. I'm assuming you already know that information. If your dashes are signifying 1 unit, you don't need to label them. But if you're jumping by 2s, then obviously you would need to tell me that. But I'm going to go up 4 dashes because of the y-intercept being 4, put a dot there, then I'm going to use the slope to find the next point. Now it's -3/2. So I'm going to be going down 3 and right 2. So I need a couple more dashes, and I would land right there. You don't need to repeat the slope anymore. I know from this information here if you know what you're doing because I can see the y-intercept, and then I can see that you used the slope to find the next point. Okay, so that tells me that you know what you're doing. Let's try this next one. Y equals 1/3 x minus 5. We need to start here, and then we need to use our slope, rise over run, up 1/3 to create that slope. Y equals 2x plus 1. Put the y-intercept there. Now, if we have a slope of 2x plus 1, that's really 2/1, because any integer can be placed over a 1. So we're going to have to go up 2 and over 1 for this one. All right, now let's answer the question at the bottom here. Which one has the steepest slope? So you have to imagine if you're skiing down all 3 of these hills, which one would be most like a black diamond hill? Okay, the steepest, scariest, quickest way down the mountain. Okay, so looking at these, I think we can all rule out this bottom graph because it's definitely not the steepest. So it's not that one. It's going to be a fight between the other two. Now let's look at the slopes. We have this and this to compare. Okay, -3/2, which is really -1.5, and 2. Okay, let's ignore the positives and negatives for this moment, this time. Okay, and just look at which one is actually a steeper hill. Hopefully you're thinking that the one with 2, the 2x plus 1, is steeper. Okay, the reason being that it is a bigger number. 2 is bigger than 3/2. So the bigger slope values create steeper lines. So that one is steeper because 2 is bigger than the other slope of 3/2. Okay, we're not talking about negative, positive, or anything like that. That just tells you what direction the line is tilting. Okay, we're just talking about how steep is it. That's going to help you on a homework problem. All right, let's review this. I know you have learned this last year. You may not remember it. Okay, but the slopes of parallel lines, let's think about it. If we have 2 lines that are parallel, what do we know about their slopes? Okay, they're equal to each other. Slopes of perpendicular lines, there's definitely some properties that are involved here. They're not going to be equal, that's for sure. Perpendicular lines. Okay, there's 2 things that happen. A positive and negative is going to be opposite. Okay, so it's going to be opposite. And then a word that as soon as I say it, you're going to say, oh yeah, I remember that. They are opposite reciprocals. So in a fraction, if you have 1/2, the reciprocal is 2/1. You flip the two numbers, the numerator and the denominator. So that's what we're going to be focusing on as far as the test goes coming up, that idea. So let's look at this. We want to know, are these two lines parallel? Remember these symbols we talked about in the beginning of chapter 3. Parallel, perpendicular, or neither. So what we need to look at is the slope. Okay, so we'll find the slopes of each of these lines. They've given us two sets of coordinates so that we can calculate what the slope is. Okay, slope of line 1. We're going to subtract the y values in the numerator. Okay, so let's go this direction. So 7 minus 5 and 0 minus 2 for the x's. We simplify this, we get -1. That's the slope of line 1 if we were to graph it. Line 2. Subtract the y values. Let's go 9 minus 8, which means we have to do what order for the x's? -2 minus 5. So let's simplify this. 1/-7. That doesn't simplify anymore. So now the question is, are they parallel? What do they have to be in order to be parallel? They have to be the same. Okay, are they the same? Definitely not. Okay, so not parallel. Perpendicular. They have to be opposite reciprocals. Okay, first question, are they opposite? No, they're actually both negative. Okay, so it's already not perpendicular. And they're also not reciprocals. Okay, so this one is neither. That is the answer for this one. There's going to be homework problems just like this. So let's talk about this opposite reciprocal idea very quickly here at the end. Here's two equations of two lines, and we want to know the slope of the perpendicular lines to each of these. These are separate problems. So looking at example A, y equals 4x minus 5. We want to know what is the slope of the perpendicular line. Okay, well, the slope of this line is 4. So we need the opposite reciprocal. So opposite means we have to change the sign. So it's now negative. And 4 is the same thing as 4/1. So the reciprocal to that would be 1/4. What would the slope of the perpendicular line be to this one? We need the opposite reciprocal here. Change the sign, flip your numbers. And we get 4/3.